When your dreams have failed you, dream again. When your dreams have failed you, dream again. Failure cannot break your heart. Life is a game, so play your part. Dare to make another start. Dare to make another start. So dream again. Next time, you will be stronger, wiser too. Next time, you will be stronger, wiser too. Think of all the things you meant to do. Keep the glory of the goal in view and dream again. Keep the glory of the goal in view and dream again. Dream again. When your dreams have failed you, dream again. So, hello, my shimmering stars. Today, I, Shaurya Grover, welcome you all to this amazing platform of PW English. Today, we are going to start our lecture number 4th based upon the chapter D and F block elements under our batch Excellence batch. I hope so, students, you have seen the previous lecture and all the topics were clear to you. So, today, we are going to wrap up this chapter over here and we are going to practice a lot of questions as well. I hope so all the topics are now you're prepared with respect to the chapter D and F block elements. Yes. So students, as you all remember, in the previous lecture, we were basically doing the F block elements and we have already done about lanthanoid series. Now in this particular session, we shall be studying more about actinoid series and then we shall be proceeding towards the practice session, right? So first of all, what are the topics we are going to cover in today's session? Topics to be covered. The very first segment, students, that we are going to cover today over here is going to be the properties with respect to lanthanoid series. Yet we have already completed lanthanoid series, but there were some of the few properties which I want you all to tell you so that you can mark in your NCERT as well as you should know them. Okay. So properties of lanthanoid series. After that, students, we are going to study about actinoid series. And its properties. Also, we are going to cover the practice session. Sorry. So let us start our today's session with a beautiful smile. Yes. So the very first topic that we are going to do are the general properties with respect to the lanthanoids, right? So general properties, I'm really sorry for this. So general properties of lanthanoids. See, if I talk about lanthanoids, understand this thing. In lanthanoid series, now you have done the atomic radii trend, you have seen the oxidation state values, you have even seen, the electronic configuration as well. So when I talk about general properties, the very first property that we talk over here is about their nature. Basically, if I talk about all the lanthanoids, they are, soft in nature and they are silvery white in nature. But if we talk about a particular element, there are some exceptions in each and every, the element in every block which I've already mentioned you that you have to mark. Now, if I talk about lanthanoids, in the case of lanthanoid, SM is the one which is steel hard in nature, while the rest of the lanthanoids they are silvery white soft in nature, right? So you need to write it down. All lanthanoids are silvery white and soft, while SM is steel hard. Now, why it is steel hard? Because it shows a high, metallic bonding. Due to that, it has a it is steel hard in nature, right? Now, when I talk about It's color. Basically what happened, all are colored except two cases. Okay, so you can write over here, all lanthanoids, all lanthanoids are colored. Now, which of the following will not be colored, students? There are two states in which we can say they won't be colored. One is when there is F0 state, and another one when there is F14 state. At that spot of time, they are not colored, but yes, the rest of the states, they are colored in nature. Great. Now, students, when I talk about the magnetism over there, all are paramagnetic except two. Okay. So, you have to write all are paramagnetic in nature. All are paramagnetic in nature. Except the two categories. Now, which of the following two categories? Except La plus 3 state. Okay, over here it is diamagnetic in nature. And Lu plus 3 state. Is it clear to you? Now, these are the properties that you should know, and you already know that you have to see the unpaired electrons over here, right? So, unpaired electrons will let you know whether it is diamagnetic or whether it is paramagnetic in nature. Now, one more thing, as I was telling you that over here, there is an exception for hardness. Let me tell you one thing. As the atomic number increases, the hardness itself increases. So, this is a rule also that you should write over here in the case of lanthanoid series, that hardness is directly proportional to atomic number. This is the direct trend which I have told you over here. Other than this, students, if I talk about the alloys of lanthanoids, they are mish metals. If I talk about the alloys of lanthanoids, they are mish metals. Now, students, mish metals basically comprises of 95% of lanthanoid. 95% of lanthanoid, 5% of iron, and rest the few traces of, sulfur, carbon, calcium. Okay, so you can mention over here that 95% of lanthanoid. Okay, other than this, 5% of iron and few traces of one second. Carbon, sulfur, calcium, etc. Right? This is what is mish metals which are comprised of. Kindly write all these characteristics so that we can move on to our actinoid series, students. Kindly write it down so that we can move on to our next part. Okay, other than these, you all know the properties. They are malleable, they are ductile. We have studied in this in the previous session. Yes. Now, students, when I move on to the next series, that is the actinoid series. If I talk about the actinoid series, actinoids. These are the elements which are present in actinoids, right? That is thorium, potassium, uranium, neptunium, plutonium, americium, curium, berkelium, californium, anstinium, ferium, mendelevium, and nobelium and lawrencium. Now, students, you don't have to remember the name of the following. When you are going to practice a lot of times, when you're going to write it a lot of times, you're automatically going to learn it. But yes, I'm going to provide you a small trick in order to remember the basic representation of the elements, so that you can write the trend when they ask you in the question. Now, what is the certain trick which I have made for the actinoid series? You can write in the comment section your trick, and the students who feel like they have an easiest trick than me, they can do that also, right? So basically, see, from thorium, now I'll tell you which of the following you have to just remember the name with the name, like thorium, uranium, which are generally asked again and again, students. Okay, now over here, these are really very important, students. These are really very important. Okay, at least their names you should remember, at least their names. Now, coming back to the trick over here, if I say from thorium, it is thoughts past. Now, from uranium, upon you, thoughts passed upon you. Okay, this is all together. Upon U is uranium. Thoughts passed upon you. Now from NP it is no problem. From NP it is no problem. No problem. From PU it is PW. From PU it is PW. Okay, right? And from AM it is army. From AM it is army. Now see what I've written over here. Thoughts passed upon you. No problem. PW army. Now from CM is coming. From CM is coming. Coming. From BK it's back. From coming back. Now there is one extra word, that is with over here. Coming back with. From CF it is confidence. Confidence. From ES it is enthusiasm. Okay, then see, basically I'm reading again. Thoughts passed upon you, no problem. PW army is, right, just add is over here. Okay, is coming back with confidence, enthusiasm, faith, mind map, notes. There is one extra word, that is and over here. And lectures. Lectures. So this is the trick which I have made for you people, so that you can learn the Actinoid series. Okay, so sometimes what happen when we practice a lot of questions and when we do a lot of topics, we get confused in them, right? So thoughts passed upon you that you feel demotivated at a certain interval of time. So at that spot of time, you should remember that thoughts passed upon you, no problem, there is no need to worry. Why? Because PW army is coming back with what? Then you have to come back, no? With great confidence, enthusiasm, faith. Now you have mind map, you have notes, you have lectures, right? So this will help you to bring all of these situations back. Confidence, enthusiasm, faith. So believe in yourself, believe in your teachers, and start working hard, students. If you have not yet started working hard, and if you are just taking all the things very lightly, it is high time, students. Wake up and do your work on time. Solve questions, daily practice questions, revise the topics that are already covered, because it will only help you, students, right? So I guess this is now clear to you. Also, I have written all the atomic numbers over here. The actinoid series starts from 90 to 103. Is it clear to you? Yes, I guess this is now clear to you. Now let us write the electronic configuration for all of them, but I want you all to write the short trick over here. And yes, do write in the comment section if you have a very easy trick, okay, other than this, so that which of the following you feel easy, you can learn that, right? Kindly write it, students. I am giving you a minute in order to write it down, so that we can write the electronic configurations. Now, when I'll talk about electronic configuration for actinoid series, as you all know that they lie under which period? Under 7th period. They lie under which group, ma'am? 3rd group. This thing lanthanoid series used to lie in third group, 6th period. They lie in 3rd group, which period? 7th period. If they lie in 7th period, my dear students, so the n value over here will be, ma'am, n value over here will be 7. Very simple. Yes. So what will be the general electronic configuration? If I talk about the F block elements, you have already done this. Yes, ma'am. What it is? It is n minus 1 F. Yes. Electrons in F subshells are how much? It is 14. So it shall lie between 1 to 14. Then it is n minus 2 D. It is 0 to 1. Is it clear to you? And then comes out to be NS2. Now you have to put n value over here as what? 7. So what will be the general electronic configuration if you need to write it down over here? Ma'am, it is very simple. What it will be if you put the value of n as 7? 7 minus 1 is 6. 7 minus 1 over here is, ma'am, 6. What it is? 6. I'm really sorry. Just kindly correct it. In the case of F, it will come 2. In the case of D, it will come 1. Okay. So n minus 2 F, and then it's n minus 1D. Okay, now coming back over here. Yes, coming back over here, it is, now what will happen? 7 minus 2 is 5, so 5F. 7 minus 1 is 6, so 6D. Now from here it is 1 to 14, from here it is 0 to 1, from here it is 7S2. Is it clear? Now that means we have to fill electrons in 5f subshell, in 6d and in 7s, right? So I'm writing the electronic configuration. I'm just writing the, I'm just filling the electrons over here. Here I shall be writing about 5f. Here I shall be writing about, 6d, and here I shall be writing about 7s. Is it clear? Now in the case of 7s, all the electrons are 2 filled. Just fill all the electrons. Let me create a line over here. You can open up your NCRTs and you can even mark over there, but I want you all to write it down by yourself because it will help you a lot. Yes, okay. Now coming up back over here, as we were writing all the electrons, so I already told you that kindly fill 2 electrons in the case of 7s. All will have completely 2 electrons in the case of, in the case of whom? In the case of 7s. Is it clear? Now comes about the filling of 5f and 6d. See, I have already told you a trick over here, that is you have to fill directly 2 electrons over here. But if I start talking about thorium, let us start from thorium first of all. Do remember that it will have 0 in 5f and in 6d it will have 2. After that, there will be no one which will contain 6d. In the case of 6d, the 2 electrons. Only thorium will have that 5f0, 6d2, 7s2. Great, great. You have to write the electronic configuration in such an order, right? So I'm mentioning the number of electrons in the case of this, that 5f0, 6d2, 7s2, like this. Great. Yes, ma'am. Okay, now if I talk about 6d first of all, because 6d is quite different from other, right? So till neptunium, it is 1 electron. Till neptunium, thorium you have already done, but till neptunium it is 1. Is it clear? Now when I talk about over here curium, it also contains 1 electron over here. And if I talk about the last element, that is lawrencium, it will also contain 1. In which? In ma'am 6d. Is it clear? Now these are the cases for 1. The rest which are left over, will contain 0 electrons in the case of 6d. Is that clear? Is it clear? Was it simple? Now coming back to the 5f. Now see, you all know, if I talk about the numbers, it is 0, 1, 2, 3, 4, 5, 6, 7, it like this, right? So over here you have to skip the number 1. You have to start from number 2. It is 0, then skip the number 1, then 2, then 3, then 4. Now see, you have to skip one more number, that is 5. Now when you are skipping one more number, that is 5, which is next number? 6. Now you have to repeat 7 2 times. Now you have to repeat 7 2 times. Now the electronic configuration of curium is really very important. I am marking it over here again. Now see, what you have done is, you have skipped 1, you have skipped the number 5, now you have to skip number 8. Now if you are skipping number 8, what will be the next number? 9, ma'am. What will be the next number? 10, ma'am. What will be the next number? 11, 12, 13, right? Now you have to wait till 13. The next one will be 14 and 14 respectively. Is it clear? Is it clear? See, you have skipped 1, you have skipped 5, you have skipped 8 number, right? But you have repeated 2 cases. See what you have repeated. You have repeated over here 7 7, you have repeated 14 14. In the previous case also, when I was telling you electronic configuration in the case of lanthanoid, I told you we repeated 7 7 and 14 14. Now which of the following are really very important and you need to remember? I shall put a star over there, right? For example, I told you about curium, it is important. Lawrencium, it is really very important. Thorium, it is very important. Uranium, it is very important. Neptunium, it is very important. These are really very important, students. You don't have to skip all of these, right? These at least you have to remember, right? Kindly write it down, students. I am giving you a minute in order to write it down. Kindly write it down. Okay, shall we proceed? Kindly, when I'm telling you to write it down, you can pause the video and write it over there. Now, moving on to the characteristics of these. Moving on to the characteristics. Now, students, all are paramagnetic in nature. All are paramagnetic in nature. But in the case of lanthanoids, I've just told you right now that yes, they are paramagnetic, but there were two exceptions over here. Right? Is it clear? Now, when I talk about its size, when we move from left to right, okay, when we move from left to right, what will be their effect on size? See, when I move from thorium towards lawrencium, what will be the effect on size? You know that when you're moving from left to right direction, the size will decrease due to increase in Z effective, right? What will happen? Ma'am, size will decrease. Now, this is a symbol for decrease in size. Why? Due to increase in Z effective. Also, what is Z effective? Effective nuclear charge. Also due to actinoid contraction. Yes, in the lanthanoids we talk about lanthanoid contraction. In the case of actinoids we shall talk about actinoid contraction. Right? Why does actinoid contraction arises? Because the poor shielding of 5F subshell. Now you have just seen it contains 5F subshell. So there is a poor shielding of which subshell? 5F subshell. In the case of lanthanoid, whose poor shielding was seen? 4F poor shielding was seen. Right? Great. Now students, coming back over here, if I talk about what is the other characteristics, they are silvery white metals. Okay, they are silvery white metals. Is it clear? Kindly write it down. Now, one more thing which is really very important, which you should know, and you can mark it over here only. That yes, from 93rd element to last elements, after 92 element, I would say, all elements are transuranic elements. They are, see, this is uranium. So after that, the elements are referred to as, I shall write over here, transuranic elements. After uranium, that is at atomic number 92, they are referred to as transuranic elements. Is it clear to you all? Kindly write it down, students. You can even mark in your NCERTs if you feel so. Is it clear? Okay, students. So this ends our F block elements also over here. Now we shall proceed towards the question segment. Now we shall proceed towards which segment? The question segment, the practice session. So the very first question in front of you is, because of lanthanoid contraction, which of the following pairs of elements have nearly same atomic radii? The numbers in the parent synthesis are atomic numbers. Basically, they are the numbers which are provided to you over here are the atomic numbers in the bracket. Okay, so they are asking you, because of the lanthanoid contraction, which of the following will have same atomic radii? Now, students, you know that due to lanthanoid contraction, what do we observe over here? We observe that when we were talking in lanthanoid contraction, when we are talking about 5D series and the 6D series, they will have almost same atomic radii, right? Because when we are moving from top to bottom, the size will increase, but after coming, we observe that in lanthanoid series there is an addition of F subshell. F subshell will show poor shielding effect, and due to poor shielding effect, what will happen? There will be no shield provided to the nuclei. Hence, what will happen? The outermost electron will tend to come towards nucleus. Hence, the atomic radii will decrease. So, which of the following? You already know that over here, if I talk about zirconium and hafnium, they will have almost same atomic radii, because there is a lanthanoid contraction, there is an addition of F subshell, due to which, due to the poor shielding, the atomic radii decreases. Hence, they become almost equal. Right? So, option number A, by just looking at the question, you can directly tell the answer. Great. So, option number A is our correct answer. Now, moving on to the next part. What is the next question? The reason of lanthanoid contraction is, over here, you have been given A option as negligible screening effect of F orbital, B is increasing nuclear charge, C is decreasing nuclear charge, while D is decreasing screening effect. Now students, you should know, if I talk about the screening power or the screening effect, what was that? If you just forget it over there, do remember this thing, that if this is our nuclei and these are the shells, okay, what happens over here? We say that we are talking about this outermost valence shell electron, right? And also we know that the inner electrons are also present. In the inner shells, electrons are also present. So what actually happens over here, this outermost valence electron which is present in the outermost layer, in the valence layer, this basically what happened, this exhibits two kinds of forces. Now what are the two kinds of forces it exhibits? Either the attractive forces by the nucleus, because yes, it is a negatively charged particle. So what will happen, nucleus will increase, will tend to bring it towards itself, because they will have attractive forces between them. Positive and negative will have attractive forces, but what will happen, these innermost electrons will have a tendency to repel them. They won't allow it to come inside. Why? Because negatively and negatively charged species will repel each other. So what basically will happen, we observe that when we are talking about screening effect, what is the screening effect? The tendency of the innermost electrons, that they create a shield over here so that this electron cannot come inside, is the screening effect. In other terms, we explain screening effect as the repulsive forces, right? Because they are repelling so that it cannot come inside. It cannot come inside. So what happens when we talk in the screening power, this is the order, right? And the F orbitals basically have the poor shielding effect or the screening effect or the screening power, due to which we see the lanthanoid contraction, right? So there the reason for lanthanoid contraction is negligible screening effect of F orbitals. Is it clear? Right. Now let us see the next question that we have over here. Which of the following lanthanoid ions is a diamagnetic? Now students, I want you all to solve this as a homework question. This is your first homework question. Your answer should be written in the comment section. It is very simplest case. Very simplest. In the previous lecture also, I have told you the general formula in order to calculate. You just have to check out whether unpaired electrons are present or not. And for that, you have to write the electronic configuration. Great. Okay. Now, let us see the next question that we have. Which of the following oxidation state is the most common among the lanthanoids? Now, if I talk about lanthanoid series, I have already told you lanthanoid can exhibit +2, +3 and +4 oxidation state. In this, +3 is the one which is the most common one. +3 is the one which is most common, yet it can exhibit +2 and +4, and I have told you which of the following can exhibit that states, right? Now moving on to the next question, we have lanthanoids are, A option over here is 14 elements in 6th period that are filling 4F subshell. B is 14 elements in the 7th period that are filling 4F subshell. C is 14 elements in the 6th period that are filling the 4F sublevel. And D is 14 elements in the 7th period that are filling the 4F sublevel. Now, if I talk about lanthanoids, basically has, they lie in the period number 6th over there, right? Actinoids lie in the period number 7. They lie in group number 3rd, both of them. So, first of all, in 6th period, either this can be correct, but this won't be correct because it is 7th period written over here, right? Now see, here it is 6th period, it can be correct. Here it is 7th period, this is wrong. Now from these two, let us see what they have written. They have written that they are filling the 4F sublevel. Yes, they are filling the 4F sublevel, no doubt. Yes, they are also filling the 4F sublevel. Now see which atomic number are being lied over here, from 90 to 103, and from here 58 to 71. You have just studied right now. From 90 to 103 are the actinoids. Are the actinoids, not the lanthanoids. Hence, option number C is going to be our correct answer. Is it clear? Simple question, right? So, I've taken these previous year questions and questions from the good book so that you can practice it out. Now comes the next question. The correct order of ionic radii of these elements is basically what? They have provided you the atomic number over here. Now students, you know that what happens when we move from left to right direction, atomic radii decreases, right? That means when we are moving from lanthanoids towards, the last element over here, if you see here they have provided atomic number, they have given you all the atomic number of the elements, then what will happen? The atomic radii will decrease, hence the initial one will have the more atomic radii, right? So you have to tell which of the following is the correct answer. I have told you the order. Atomic radii will decrease when you're moving from left to right direction in a period. Right? Now let us see the next question. The reason for greater range of oxidation states in actinoids. Now you know basically in lanthanoids we exhibit +2, +3 and +4, but in the case of actinoids it is quite different. You can see variable oxidation states as well. Okay, so they are saying the greater range of oxidation state is seen in the actinoids is due to, first is actinoid contraction, second is 5F, 6D and 6S levels having comparable energies, C is 4F and 5D levels being close energies, 6 is the radioactive nature of the actinoids. Yes, one more thing I forgot to tell you, almost all the actinoids are radioactive in nature, right? Now when I'm talking about the reason for the greater oxidation states is due to the comparable energies of 5F, 6D and 7S. Great. Okay, now let us see the next question. Which of the following exhibits only +3 oxidation state? So this I have already told you. This is very simple, students. Let us write it over here. I guess we have forgotten to write about the oxidation states. Yes. So let us write over here. If I talk about uranium, basically, students, uranium can exhibit different oxidation states. For example, +3, +4, +5, +6. All of these it can exhibit. So over here you can write if you want to. It will show +3, +4, +5, +6. As I've told you, in the case of, lanthanoids, we observed +2, +3, +4. But over here, we can see variable up to +7 also. So uranium can exhibit +3, +4, +5, +6. Right? If I talk about if I talk about other elements, if you want to write it over here, let us talk about, protactinium. That is the atomic number 91. It can exhibit +3, +4, +5. There is a table of oxidation state that is provided in your NCERT. You can read it from there. It will be clear to you people, right? Now, if I talk about the other elements, like we have talked about this one. Now, if I talk about, over here, about neptunium, it will show +3, +4, +5, +6, +7. Similarly, we can see of other elements also. Now, if I talk about thorium, we can say it can exhibit +3 oxidation state, +4 oxidation state. See, very simple trend that you observe it over here. It will exhibit +3, +4. It will exhibit +3, +4, +5. It will exhibit +3, +4, +5, +6. It will exhibit +3, +4, +5, +6, +7. Like this, and then it will start on decreasing again, right? So if I come back to my question, let me tell you over here, where is the question gone? Yes, if I talk about only +3 oxidation state, so that is seen only by actinoid. That means option number C will be your correct answer over here, right? Let us see the next question. More number of oxidation states are exhibited by actinoids than by lanthanoid. The main reason is, now just I have told you, the main reason is the comparable energies of the 4F, 6D and 7S respectively. So let us see the options over here. More active nature of the actinoids. Second is more energy difference between 5. I have told you comparable energy. So basically, this won't be our correct answer. Lesser energy difference, yes, because there is a comparable energy between them. So less energy difference between 5F and 6D in comparison to 4F and 5D orbitals. So option number C will be our correct answer. Let us see the next question that we have. In the neutral for faintly alkaline medial, KMNO4 oxidizes iodide into iodate. Now this we have already done, students. Already done. I told you, whensoever you're taking the neutral medium, in that case MnO4 negative. Okay, when it will react with what? When it will react with I2. Basically, in this condition, they are saying iodide. So in this condition, we are taking iodide. It will convert into IO3 negative, if you remember. Also, we see that Mn from +7 oxidation states move to which oxidation state? +4 oxidation state. That means from MnO4 negative, it will convert into MnO2 in +4 oxidation state, right? So over here, the change in oxidation state of manganese is from +7 to +4. We have done the cases of acidic medium. I have given you different reactions. We have done the case of neutral medium. I have given this reaction in the previous lecture. If not seen, kindly go and check over there. Again, the same question. When neutral or faintly alkaline KMNO4 is treated with potassium iodide, iodide ion is converted into X. It is converted into IO3 negative. Yes, simple question. Now moving on to the next question. K2Cr2O7 on heating with aqueous NaOH will give. Now this is, students, your homework question. You have to do on your own and you have to write the answer in the comment section. This is the question number 3. It is very simplest question. Moving on to the next question, we have which of the following ions has the electronic configuration as argon 3d6? You have been given with certain elements in different oxidation states. Again, this is your homework question. This is your question number 4th, right? Okay, now comes the next question. They are saying among the following series of transition metal ions, the one where all the metal ions have 3d2 electronic configuration is. They have already provided you the atomic number. For example, they have given you the atomic number for titanium, that is 22. Now, when you are going to write its electronic configuration, it is what? It is 3d2 4s2. Now we have to see, we have seen titanium here is in +3 oxidation state, +1 oxidation state, +4 oxidation state and +2 oxidation state. We want electronic configuration should come out to be 3d2, right? How 3d2 will come? When 2 electrons will be taken out. That means when titanium is present in +2 oxidation state, its electronic configuration becomes 3d2, which they want. So in which of the following is titanium is in +2 oxidation state? So we have directly answered option number D. But if we want to cross check, you can cross check all the given options over here. For example, let us take another case. Let us talk about chromium. Chromium 24 oxidation number. 24 atomic number. What is the oxidation electronic configuration? If you talk about over here, you can directly write about this also, right? It was 3d5 4s1. Yes. Now when we talk about this case over here, we have to remove how many electrons? See, if you have to cross check, we have to remove 4 electrons. That means 1 electron from here we are removing, right? How many electrons are still left? 3 electrons. 3 will be removed from here. What will be the electronic configuration? 3d2. Yes, it is correct. So option number D is our correct answer. Is it clear to you people? Is it clear to you all? Okay, shall we proceed to the next question? Now, which of the following has more unpaired d electrons? Now, you have to write the electronic configuration, right? Its answer. Again, this is question number 5 as your homework, right? Now, let us see the next question. The calculated spin only magnetic moment of chromium +2 oxidation state is what? Now, you should know this formula that if you have to calculate the magnetic moment, now the formula we know is root n plus 2 Bohr magneton. N over here is number of unpaired electrons, right? When I talk about chromium 24 atomic number, it is what? It is 3d5 4s1. Chromium +2 oxidation state, that means we have to remove 2 electron, one from s and one from here. It will be 3d4 over here, right? That means n value over here is what? 4. Now you have to initiate n value as 4 over here. It is 4. 4 plus 2, what we will get? Root into 4 into 6, then we will get root 24. Now you are going to solve it and you are going to get your correct answer over here, right? Is it clear? Is it clear? By this way you have to solve the questions. You just have to write the electronic configuration and hence you will get your answer. Now moving on to the next question. Which of the following can react with K2Cr2O7? Again the same question which we have already done in the previous lectures. So you have to do it as a homework. This is question number 6. Now comes next question. Dichromates, are generally prepared by the fusion of chromite ore with sodium carbonate, potassium carbonate, both A and B over here, right? And then they're talking about neither A nor B. So this is again as your homework. Dichromate we have done. We have also drawn the structures of chromate as well as dichromate in the previous lecture. Let us see the next question. Permagnetate ion they're talking over here is dark purple colored through Mn is in +7 oxidation state with D0 configuration. This is due to, now students, this is due to the charge transfer from ligand to metal. This is the reason why here there is no DD transition, because there is no unpaired electrons in the case of Mn +7 oxidation state. When Mn is present in +7 oxidation state, there shall be no unpaired electrons. When there are no unpaired electrons, there shall be no DD transition. But many of the students may mark first A option because they will directly see DD transition, hence it is correct. No, but it is incorrect. Why? Because there is no unpaired electrons, so there is no DD transition. There will be charge transfer from ligand to metal only. This is a very different kind of question. Now moving on to the next question, we are saying that if we talk about all the actinoids are believed to have the electronic configuration of, now you have to tell which of the following is the correct. I won't tell, it is very simplest answer. Yes, I won't tell you. This is what you have to tell. All the actinoids are believed to have the electronic configuration of which of the following. Great. This is very simple question. Now moving on to the next one, what will be the most common oxidation states which are shown by the actinoids? Again, the most common over here is also +3 oxidation state. Great. Now moving on, yes. Students, now comes your homework part. This ends our practice session as well. So your homework for today, students, is to solve the questions given in lecture, solve question given in lecture, and yes, read your NCERT. Read the uses section of lanthanoids and actinoids in the NCERT book itself. Yes. So we end our today's session over here. I hope so. All the topics were clear to you. And this ends our DNF block chapter as well. So we shall be meeting in the next lecture. And if you feel any doubt, any query, or any topic you want to re-revise, or you are feeling that no, ma'am, we want again its explanation, so you can write in the comment section. We shall discuss in the next chapter starting before initiating the next chapter. So I'll meet you in the next lecture. Till then, keep smiling, keep learning, and yes, do solve the questions which I've given you over here in this practice session and write its answer in the comment section below. Thank you so much and have a good day, my dear students.